In an emergency, police response times are measured in seconds. To shave those seconds down, departments are investing heavily in rapid, remote response drone programs. These specialized aircraft are high-performance machines, outfitted with high-resolution thermal payloads and heavy-lift rotors. However, the physical aircraft is rarely the part of the program that fails. The true vulnerability is the wireless network connection, the invisible tether, bridging the aircraft to its remote operator. Even the most advanced aviation hardware becomes a liability if the data transmission stalls mid-flight. This invisible tether must simultaneously push complex command signals up to the drone, while pulling a massive high-definition video feed down to the ground. This data pipeline faces three specific engineering bottlenecks: bandwidth limits, signal loss, and video latency. When one of these choke points closes, the operator is flying blind. High-definition aerial surveillance requires high bandwidth, a wide, uninterrupted pipeline for data to travel through. In dense urban environments, those wireless frequencies hit physical barriers. Concrete and steel degrade the signal, leading to significant signal loss. These physical obstructions effectively squeeze the pipeline, reducing the volume of data that can reach the ground. For an officer on the street, this results in a degraded, unreliable video feed. Ground-level operations are inherently hostile to the high bandwidth requirements of modern police drones. Choked bandwidth leads directly to video latency, the dangerous delay between an event happening and the pilot seeing it on their screen. This delay creates a tactical gap. On the left, we see real-time action. On the right, the multi-second stutter caused by latency. In remote operations, this gap is critical. A pilot reacting to a 3-second-old video feed cannot make effective tactical decisions in the present. Latency transforms an active surveillance tool into a delayed, unusable record. To bypass ground-level interference, network design must move upward. Strategic rooftop launch points, like this automated docking station, act as elevated network nodes. These stations provide an immediate, unbroken line-of-sight signal that travels above the urban clutter. Elevating the infrastructure is the only physical way to guarantee the necessary high-bandwidth data pipeline. Imagine a remote operator deploying a drone to an emergency miles away. This path depends on an optimized network. The data travels from the control center to the rooftop relay, maintaining a solid connection to the aircraft. This architecture prevents dropped frames and maintains the real-time feed required for command and control. Successful scaling requires the network infrastructure to expand at the same rate as the fleet. Bandwidth, latency, and interference remain the primary limits on these operations. Ultimately, the absolute mastery of this invisible wireless tether is what dictates the success of every remote police mission.